Hello friends, Namaste, welcome back. First of all, thanks for watching my previous videos on artificial intelligence and thanks for liking and sharing the videos. Today we will be discussing the artificial neural network. We'll take step by step. We'll start from the basics to the advanced level. I will give you the introduction, then the difference between the linear versus non-linear. We'll show how a single neural network known as Perceptron, when it was invented, what were the drawbacks and even what were the uses. Then we will discuss artificial neural network called ANN. So to start with, I would strongly recommend, if you have not seen my previous videos, kindly go through it since we have covered this topic previously as well. So artificial neural network is purely inspired from the human brain. So this is just an example that we are showing here, how the neural cells within the brain looks like, how it processes the information, and how it looks like. Here you can see the input signals. They are nothing but the dendrites. We call them dendrites. The input signals comes to the dendrites and it can come in thousand different neuron cells can pass the information at the same time to the dendrites. It acts as the input signals. It gets processed and the output signal is generated from the axon terminals. So if you see the average human brain, you will be surprised to know has more than 80 billion neurons, and each neuron may be connected up to 10,000 other neurons. So passing signal to each other, it could be more than 1 trillion connections. So you can see how complex the human brain is. And to replicate same, since as I said, artificial neural network is purely inspired from the human brain. So same has been tried. It's an attempt to replicate the same so the network can be established. Since we are talking about the brain, some small facts about it I will quickly tell you so that you will understand uh, how we are using it. This image has been took from the Wikipedia. In our brain we have two parts. We call it left hemisphere and the right hemisphere. The left hemisphere, the blue part, you can see it mainly deals with your reading, writing, speaking, arithmetic reasoning. So it has been seen the people who do lot of activities related to arithmetic calculations, so the activities are more in the left hemisphere. And the best part about the left hemisphere is it processes the information sequentially. Similarly, in the right hemisphere, it takes care of your pattern recognition, emotions, music, etc. And it processes the information as a whole, individually. Example, if it hears the word called cry, glass, it immediately starts relating it with cut or something like that, since it processes the information individually. So this is about how neural networks, artificial intelligence, and machine learning is inspired from the human brain. So you can see how complex it is and how we want to achieve it through the programs and algorithms. So any person who is starting the journey for AI, so the basic building blocks is from mathematics perspective also. People should know. Let me zoom it so that it is purely visible. It is very important to understand the concept you might have learned in your school days, linear versus non-linear. So in a layman's language, I would say on a Cartesian plane, a linear function, this linear function, is a function where when you try to draw a graph, it should always be a straight line. The line can go in any direction, that doesn't matter, but it should always be a straight line. And a non-linear function can never be a straight line. It can be of any shape. So that becomes the non-linear. The name itself suggests that is non-linear in nature. The classic example, I won't take here much time, it's self-explanatory. The classic example of linear function is y is equal to mx, where m is the any constant, 5, 10, whatever you want to see. So let's say if I try to draw a line where my x varies from 1 to 10 and my y is equal to m of x. Let's say your m is 5, 5 is the constant. So what will happen? You just multiply the number with the 5 and try to draw. This is your x-axis, y-axis, and you can see you are getting a straight line. So it's nothing but a with different slope, with slope of 5. So you are getting a straight line in the linear function. Now if we talk about non-linear function, non-linear is where the output is drastically changing and it's not linear with the input. There you have seen it's linearly increasing. The classic example is y is equal to x square. So let's say your x is ranging from 0 to minus 9 and same to 0 to 9. So if you just look at it, you have to just take the square of it, and when you try to draw it, you are getting a kind of a hyperbola kind of thing. So it is completely non-linear in nature. It's since in all our artificial neural networks, in the algorithms, we use non-linear functions. That is the reason I'm explaining here. The non-linear functions we need to introduce into the artificial neural network so that it gives already you have a linear function, and when you add non-linear to it, it helps in the output, since the output cannot be reproduced from a linear combination of the inputs because it will always be same. So this is the another reason very non-linear. Once we will go to the activation function, I will explain that part as well. I will make it more easier for you. Now logical gates, you all have studied the gates. Logical gates have a truth table where they will give some yield the value. So still we are purely talking here about basic mathematics and the digital design. Slowly you will see how it gets transformed by using the perceptron, and then how artificial neural network can be, you can realize it, and you can, it makes your life much easier in understanding. So you all know about and gate, where you have the input a b and output will be a b. So if you see the truth table, simple concept, whenever both the inputs are or the, I would say the current is passed to the or the signal is given, you will get the output 1. In all the three cases you will have 0. So when you try to draw it, look at carefully. Here your value black does mean 0, 0, 0. The green one is where you already have a value of 1. Now let's say the system should be smart enough, it should automatically detect what should be the best fit of line. If you see, if we segregate, so this is the perfect line that can come, that will differentiate between the two inputs and outputs, correct? You have a 1 in as a output, and here you have a 0. So this line can immediately differentiate it. Similarly in the OR, if you see, or you all know either of the signal, if it is 1, output will be 1. Same we have to try to draw it. It's self-explanatory. You can see here. Here the output is 1, 1, 1. Here it is 0. So you can bifurcate it. Okay. And now coming to the XOR. Similarly, we have other logical gates. XOR, you can see the output in this case is 1, 1, but in both cases is 0. So if I have to segregate the, since you can see in between this is 0, this is 0, in between we have 1 and 1. If you have to bifurcate it or try to divide it by a single line, it is not possible. That is the biggest reason when you will learn perceptron in the next tab, you will understand that perceptron, through perceptron you can realize or achieve AND gate, OR gate, but XOR condition you can never get or achieve through perceptrons. That is the reason, this is the first drawback of perceptron. That is the reason we have artificial neural networks, to overcome such situations where we have hidden layers. I will explain that part. Now coming to perceptron, you might have heard Actually, perceptrons were developed in 1950s and 1960s by the scientist Frank Rosenblatt. The You can see here, let me show you so that you will, if you see very carefully, perceptron, what exactly it is. Perceptron is a simple prediction where you have a weight and the bias. If it is greater than or equal to 0, the outcome will be 1. If it is less than 0, the outcome should be 0. This is a simple prediction. It's a binary prediction that is used in the perceptron. So perceptron, you can also call it, it's a single layer neural network, single layer. And if it's a multi-layer perceptron, then it becomes a neural network. But here we are talking purely about perceptron with a single layer. What that what does that mean? That also I will explain. Let us take a simple, it's pure mathematics. Too simple to understand. Just follow me. If you look at the truth table of the AND, you will see we have input x1, x2. In the If you see when it is 1 and 1, both the inputs are 1, then it yields the output as 1. Now what formula we have? F of y is equal to weight 1 x1 plus weight 2 x2 plus bias. So let us keep it constant. My weights will be 1 as of now, and let we give the bias minus 1. It is all purely we are giving trial and error methods. Okay, you can try yourself by giving random numbers. Bias is minus 1. So we are trying to find here the weight and the bias so that we can get the output in the same fashion. That means my perceptron is ready to use. Let's say row 1, if you substitute the values, x is 0, so 0 plus x2 is 0, 0, and bias is minus 1, minus 1, so outcome is minus 1. So is minus 1, since I said the prediction goes like this, wx plus b, if is greater than or equal to 0, then the outcome is 1, and if it is less than 0, then always outcome should be 0. This is the perceptron rule. So here what should be the outcome? 0. You got the outcome 0, it means yes, first condition is pass. Let's go to the second condition. Now in this case, what is the x1? 1. 1 plus what is your x2? 0 plus 0 minus bias value. Bias value is minus 1. What came the outcome? 0. But what is my condition? When wx plus b is greater than or 0, my output will be 1. That is how the prediction happens. This is the simple formula. If you have not seen my previous videos, kindly go through it where you will understand what is weight and bias. So in every machine learning algorithms, you will come across the weight and the bias. So if you see, I have highlighted it in red. With my these conditions, it is not able to fulfill. The second condition is failed. So my perceptron is not ready. I am not able to realize, since I am not able to generate the output. That is what I was looking for with these values. Let us try to change the bias from minus 1 to minus 1.5 and do the same activity again by passing the parameters. Simple. Now the condition that got failed earlier, let's take the same condition. x1 plus x2 plus bias is minus 1.5. 1 minus 1.1.5, outcome is minus 0.5. So is wx plus b greater than or equal to 0? Okay, so it is not greater than or equal to 0, it is less than 0. So again my outcome is 0. So if you see, by giving the values, it's all trial and error. I'm not saying that bias with minus 1.5 only you will be able to achieve. You can give different values. You try with 20, 30, 40 different numbers you try to give. You will be able to achieve it. So what does it mean? If we have to replicate the AND gate, what should be bias? Minus 1.5, and what weights I have to set? 1. Similarly, you can set another ones. So if I have to draw it, it looks like something like this. That's what I was saying you. It's a single layer perceptron. Simple. Two inputs x1, x2. It can be any value. In our above case, you have seen we have given the x1 as 1, x2 as 1. We kept on changing the bias. Earlier we kept 1, but it failed. But when we gave the value as minus 1.5, we were able to get the desired output of AND gate. So you have seen we have used the logic of perceptron to achieve the AND gate. Similarly, you can get the outcome for OR gate. You can try it also yourself. It is very easy. You have to keep in mind the output and the prediction. If wx plus b, weight into input plus bias, is greater than or equal to 0, then the output will be considered as 1. If it is less than 0, then the output is 0. This is the basic thumb rule of binary classification using perceptron. As I said, you can search also and study also. The XOR we can never be able to replicate using the perceptron. Reason, as I earlier said, since you are getting two different planes, it is not possible to replicate it, because between the two inputs where you have the 0 as an output, if you see these two, you are getting the values this, so we cannot divide it. To get that value, we need neural networks. Through that only we can achieve it. So I can give you a small example also. You can try it also. Let's say I have a very real-time example. I am waiting for a job offer where my condition is, if the job location is in the same city, if the technology is good, then the distance from my home to office should not matter at all. So my first condition, as I said, so first condition will be job location. My second condition is technology. And the third is distance from home to office. So these are my three conditions. If you see, the inputs are three: x1, x2 and x3. Now what matters a lot for me, let's say job location is very important for me. I weight it more since I want to be in the same city. Second priority is the technology. Distance from home to office is the least priority. So what should happen? If you have to derive the output for it, what should happen? The weight that you will assign to the job location will be much higher than the technology and the distance from home to office. And the parameter that x3 in this case, distance from your home to office, doesn't matter you much. Its weight will be less. The higher the weight it is, the higher you're giving the preference and the prediction inclination towards it. Now, if I talk about artificial neural network, before touching the artificial neural network, you can see here how it goes. We have a set of inputs as we discussed. We apply the weights to the inputs. We take the summation of it, as that's what we did in the previous perceptron example, and then we apply the activation function to it. Now you must be thinking, what is activation function and how it can help us. Actually, neural networks uses different techniques to minimize the error or the loss by using back propagation methods called gradient descent that calculates the weights of different layers. So if you see, let me show you how activation function helps us. If you see here, activation function, keep in mind, will always be a non-linear function, as I said, because it helps the linear functions. When we add the non-linear function, it helps the neural network to train and predict the things. Otherwise, if we keep on adding the linear things in the linear, it doesn't help at all. If you see here, We have different type of activation functions. Mainly four are used, that's what I have explained here. One is unit step that you might have heard. You can see simple. When it is 1, the output is constantly 1. And if it is 0, it is constantly 0. So this is the first and basic activation function that will help in differentiating the output. But the biggest problem you can see here in the step function, you yourself can see it normally fails in this particular condition when the values are near to 0. That time we have the issues with it, especially in gradient descent we face such issues. So to overcome this problem, the problem that I mentioned, the step function, as I said, this one is non-differentiable at 0. As I said, when I say non-differentiable, you cannot differentiate whether it is 1 or 0. Okay, and it fails in gradient descent approach, and it fails in the task of updating the weights because it gets confused, it gets lost. So to overcome this problem, we have a sigmoid function. You can see here this activation function we are talking about. When we add this, multiply with the sigmoid function, we get the output. So sigmoid function, these all are, as I said, nonlinear functions. So the sigmoid function is another type of activation function where it scales the value between 0 and 1 just by applying a threshold with this formula. F of x is equal to 1 by 1 plus x exponential of minus x. We have one more type of sigmoid function, the advanced one. It's very similar, hyperbolic tan. You call it tan h as well. So the tan h function is another type of activation function which will rescale between minus 1 and 1. Sigmoid goes from 0 to 1, but the tan h goes from minus 1 to 1. It just applies a threshold, very similar to the sigmoid function. The only advantage we have of tan h is that it is zero centered. If you see properly, it is zero centered. The diagram itself shows. Okay, so it helps. Then we have one more function called ReLU activation function. This is one of the most important and widely used activation function. It has lot of benefits. It allows the values which are positive and negative values are not passed at all. If you see, all the negative values are negated and it just considers it 0 only, and all the positive values are considered. That's why you can see the max of 0 comma x. Still, now as I said, same issue we will face. There is only one drawback to this ReLU function. That is a case when we have a result of dead neuron while backpropagation. Backpropagation using gradient descent is a technique through which we change a small value in the weight so that the network trains itself and tries to regenerate the output. It keeps on training, rectifying the error, minimizing the loss. That's how the neural network learns. Now the question comes, which which activation function we should use. So sigmoid function, their combination usually work very better with binary classification, zeros and ones. Sigmoid function, you can see here, since the value is ranging between 0 and 1. Tan h function, we normally don't use it since it faces a problem of dead neuron, as I said. But still, in place of sigmoid, we can use it. ReLU is widely used activation function, and it yields much better results than sigmoid and tan h. We have few more, but we'll not be discussing it here. We have leaky ReLU that solves your problem of dead neuron in the hidden layers. Then there are few more activation functions that you can search over the internet: linear, soft plus, hard, sigmoid, extra, extra. But the core concept is same. Now, as I said, neural network and difference of neural network from the perceptron is your perceptron is a single layer neural network, and the moment your single layer neural network is changed into multi-layer, then it becomes the neural network. And neural network looks like something very similar to this, where you have input layers, hidden layers. It can go till n: hidden layer 1, hidden layer 2, hidden layer 3, and the output layer. Let's say you are giving the input as some, you are doing some binary classification. You are giving cat, dog, and an elephant, and it is processing through different various stages, and you get the output here. If you have passed the cat, different features will be extracted in the hidden layers and try to map with the maximum prediction. So it should give you the output as cat. If it is not giving, it means it's wrong. We need to train, we need to give the proper, the weight needs to be adjusted accordingly. So network starts to take up those values, and we add the activation function. As I said, activation function helps it. So perceptron methods are very similar to neural network, which is as follows. If you see what we do, we first initialize the weight, values, and bias. That's what we have done here. If you see here, what we have done is we have initialized the weight values and the bias values. It does the forward propagation. If you see here, as I said, it is a feed forward network. But in neural network, it takes further steps. It checks the error. Then if there is lot of loss, if there is error, it back propagate and adjust weight and bias. And it keep on repeating for all the training examples. So this is how your neural network looks like. So we have different type of neural networks that you can search over the internet also. For text to speech, we use NLPs. We call it natural language processing. For recognition of image or image classification, we have different algorithms. So you can go through it. We have digital signal processing, DSPs, text to speech. If we have to find the words in a particular paragraph, so we have a different algorithms for it. Before closing today's call, I will quickly show you a small example of what we discuss. This is Google's Tensorflow Playground. Very simple. Here you can decide. I will give you a brief demonstration of it. It's very simple, easily understood. These are the different data sets as an input. This is exclusive OR that we were discussing, where we were facing the issue in the perceptron, but in the neural network it will perfectly predict fine. Let's say you have selected the circle as a data. How many neurons you want? Hidden layers. Let's say we want two hidden layers. That's what I was discussing with you. Activation: ReLU, TANH, sigmoid, linear. These are different parameters. You will slowly understand. If you have seen my previous videos, you will be able to relate it. We have two types of problems. One is classification. When I say classification, it could be binary classification 0 1, or image classification, whether it's cat, dog, or you have a regression problem where you want to predict something different. So you can select it, you can play it, you can see how it is training. It's sending the data, it's back propagation, training loss. You can see the loss that I was, loss is getting lesser and lesser. You can see here the difference. It will try to segregate very properly. The blue color neurons needs to be well segregated from the rest of the orange ones. So color shows data, neurons, and weight and values. If even if you click, you can see the weight also, how it is varying. Weight is 4.2, 3.8. Okay, I hope you enjoyed this short video. Thanks for your time. You have any questions, please feel free to write in the comment section. There are a lot of already available material over the internet. Lot of PDFs are available. Lot of research and white papers has been published. Kindly go through it. It's a starting point. Thank you. Thanks for your time.